Good morning, everyone. So welcome to CADVision System Webinar session today. So today's title is SolidWorks Inspections AQL. So I'm your presenter of the day. So my name is Ray. So obviously today topics will be focusing on SolidWorks inspections. So mainly today we'll talk about the AQL. Okay. So in this webinar sessions, basically we'll talk about how do we use the AQL tables in our design process. So basically geared towards like SolidWorks user who want to learn more about SolidWorks inspections and how can they use in your manufacturing process. Okay, but first, so what is SolidWorks inspections? Okay, so SolidWorks inspection, so it's a first article inspection. So it's an in-process inspection software. So that it will streamline and automate the creation balloons automatically and the drawings and report as well. So in SolidWorks, so in SolidWorks inspection we consist two types of inspection. So one is standalone, so which means don't need a SolidWorks CAD to run a SolidWorks inspection. So we also have a SolidWorks add-in inspections. So by using SolidWorks add-in inspection with your CAD, so it give you a free integral solution. So in SolidWorks add-ins, so it will enable user to leverage their legacy data. So regardless of whatever they have in SolidWorks file, PDF or TIFF. Okay, so basically by using SolidWorks inspections, it's very simple and intuitive applications. So basically it will reduce the time needed to create inspection documentations. So it will save up to around about 90% of your time. Okay, and also eliminate like the input errors, human errors. So therefore it will achieve the higher qualities inspections and also reduce the times to market. So in SolidWorks inspections, basically we have SolidWorks Inspection Standard and SolidWorks Inspections Professional. So the difference between SolidWorks Inspection Standard and Professional. So in SolidWorks Inspection Professionals, so we're able to extend the capabilities by giving user multiple ways to enter the measure values. Okay. So for example, we can direct input the data from CMM machine, which is the coordinate measuring machine. So however, in standards, we cannot do that. Okay, before that, I'll go through. So basically, in SolidWorks, so this is, so there's a tab here, which is SolidWorks Inspections. There's an add-in. This is a SolidWorks Inspection add-in. So when I click to a new project, I want to begin to start the project. So I just pick my template. So over here, in the general setting, so after I link in my part numbers, part name, part revisions, document number, document name, document revisions, when you can key in vendor by who, what's the job number, and then you also can put in the balloons number, start for number 1, going clockwise. So okay, and then in the sampling right here, so this is the one I would like to focusing on today. So over here, you're able to see this lot size. It means that what's the quantities you're going to manufacture these parts. What's the quantity you're going to manufacture? Level, the strictness of the inspection levels. Then also select the type as well. And then over here you got the AQL. Okay. So AQL basically is this we'll talk about later. AQL. So for today, I will be focusing on the stampings. Okay. You talk about AQL, how do we apply AQL, what's the use of the AQL tables, something like that. Yeah. So as you can see here, SolidWorks Inspection will automatically add in all the balloons automatically. For today, we're not talking about the inspections. I'll just minimize my SolidWorks. Today I will go through this AQL. So if you wish to know anything more about inspections, if you need any demo or any knowledge about SolidWorks inspections, so later today you may email me. Yes, I will be giving my email at the end of this presentation. So AQL. So basically AQL stands for acceptable quality limit. Okay. So commonly we refer as AQL. So the standard definition of AQL is actually the maximum defective percent, or you can say that the maximum number of defect per 100 units. So there's a standard definition of AQL. So in this AQL, basically is widely used to measure a production's order sample to find whether or not the entire product's order has met the client's specifications. Okay. So the customer have to take the data to make an informed decisions to accept or reject the lots based on the EQL result. Okay. So it means that sometimes you set up the AQL, the limit. However, the last decision still come back to the clients. Even it exceed, for example, even it exceed the major defects, the component is exceed the major defect percentage. However, the last decision still go to the clients, whether they want to accept or reject the lot. So in the SolidWorks inspections, the AQL, we will look at three types of defects. So of course, the first one, the minor defect. So if something is not very important, the defect. Okay. So definitely there are some, for example, there are some departure from specifications. But actually, for this defect, most of the user will not mind that. Okay. So basically, you will not likely to affect the usability of object as well. It might just be some of the not imperfect view, but it doesn't affect the usability. So next one, other than minor defect, we're going to major defect. Okay. So major defect basically, if you have more than this, you have some major defects, so the products usually will not be considered acceptable by the end user. Okay, so basically major defect will cause your products not able to use, or it will be easy to create failure. So basically they will fall into major defect category. So the last one will be the critical defect. So for critical defects, it might cause the user harms, or the regulations are not respected, or it will be dangerous to use. So basically, most of the manufacturer, if they have one major defect, critical defect, they might need to manufacture it, the whole thing. Okay. So in the bottom there, I wrote out the widely used setting for consumer goods in China. as we know, China is one of the largest manufacturing in the world. So they got a lot of industry. They're producing a lot of products. Okay, so in China, so how they set up the standard for the defects. So as you can see here, they set up 0% for critical defects. You cannot have any difficult defects in their products. And also for the major defects, they only can accept up to 2.5% of major defects. Anything above 2.5%, they will reject that. And for minor defects, they will keep it at 4%. If you did 4%, they will just keep it. Of course, these proportions vary in function of the products and its market as well. So for example, if you're manufacturing airplanes, okay, so you will not follow this setting. Okay, we will not follow this 0% critical, 2.5% major defect, 4% minor. If you're manufacturing something like airplanes, it might be 0% critical defects, 1% major defects, or 1% minor defects. It will be much lower the AQL limits, as the airplane is something you have to manufacture well. Okay, so when we're doing manufacturing some parts, so how do we know how many stock we need to take out to do the inspection? Okay, for example, you manufacturing 3,000 parts. Should I take out 100 components to do the inspections? 200 or 300? So we better know that. Okay, because if we do a 100% inspections, it will be time consuming. We eat up a lot of times. But if you don't take out 100%, it doesn't know how many samples to check. Okay, then how do we know the batch is accepted or rejected based on the sample you took out? Okay. Now, of course, lastly, when you all these things you can do by using the AQL table. Okay. So by using the AQL tables, so the buyer and the suppliers, they both must to be agree on the AQL. They will be agree by using AQL tables, agree on the defects, the setting of the defects, something like that. So how do we use AQL table? Okay. So AQL table, you can determine the sampling size we need to inspect. Okay. So according to based on your order quantity and your level of severity. So from there, in the AQL table, it will tell you how many sampling size you have to take out to do the inspections. Okay. So about the level of severity, we also have level 1, level 2, or level 3. Okay. So level 3 basically is the most strictness. Okay, strictness testing. So level 1 basically is the least. Okay. So currently in the market, 98% of the people are using level 2. So level 2 basically is the recommended level. So it falls in the middle. Okay, it falls in the middle. And of course, by using different inspection level, so it will command different number of sampling you need to take out to inspect. Okay, it means that the sampling size doesn't affect just only on the quantity that you manufactured. It also affect based on your level of severity. Okay, so here, what you can see here, this is the standard AQL table. Okay, so on the left hand side, you see the loss size. Okay, the loss size. So the loss size is the quantity of each product. So it's a loss size. So and it's also advised to perform separate inspection for each lot. Okay. So here we also can see the general inspection level. So the left hand side, the side is how many components you manufacture. So if you're manufacturing 3000 components, you fall under here. So 1200 to 3200. Okay. So in the general inspection, you go to fall into level 1, 2 or 3. Okay. So for examples, let's make an example. For example, a company is doing a production with 4,000 unit with the acceptable quantity limit is level 2. Okay. So if we look at this table, 4,000, it will fall on this row. So between 3,200 to and 10,000. So 4,000 is fall over here, and we want to use level 2. So level 2 will be the alphabet L. Okay, will be the alphabet L. Okay, so once you know the alphabet L, then so we can move on to the next table. Okay, so in AQL tables, you have two tables. One is this one, assembly size code letter. Another one is single stepping plan for normal inspection. Okay, so over here, once you get the alphabet L, which is over here, alphabet L, once you get this one, so in the next table, if you look at alphabet L, okay, so alphabet L is for over here, okay, and then the next column will tell you how many sample size you need to take out. So you say 200, okay, so you have to take out the sample size in different stage. I mean in different time of the manufacture. Don't take it out. Don't take the 200 out in the first. Don't take the first 200 out. You might take the first 10. In the middle you take another 20, and then you take another 40, then 30, and then the last batch you take another 20. So just separate it, so you get a more accurate result. Okay, so we will take out 200 components, 200 parts. I mean 200 parts. So for the settings, the acceptable quality limit setting. So as I say, the most commonly used is 0 for the critical defect, 2.5% for the major defect, okay, and also 4% for the major defects. Okay, so you go back to this table with the sample size coding, the L 200. So for this 0, that means 0 for the critical. So over here, this 0 will be the critical. This will be the critical. Okay. So indeed, if you look at the 0, if you look down, you will see 0 and 1. Okay. In L row, 0 and 1. So it means that if you have any critical parts more than one or one, okay, that means you have to reject the whole batch. Okay, you only can. So in 0, it cannot afford to have any critical defect. Okay, so they fall under 0. Okay, so next you look at the major defect. So which is 2.5%. 2.5%. Okay, so we look at 2.5%. Okay, 2.5%, and look at row L. Okay, so you can see number 1 and number 2. Okay, so it means that you can only have one major defect. Okay, you can have one major defect. You cannot have more than one major defect. If you're having two major defects, it means you have to reject the whole batch as well. Okay. Okay, so if the left hand side one, you see the 1 is for the AC. AC means acceptance number. While the 2 is for RE. RE means rejection number. So for 2.5% major defects in row L, we only can have 1 major defects. If more than 1, you get 2 major defects, the whole thing will be rejected. Alright, okay. So next one, you look at the minor defect. Okay, minor defect. So minor defect is 4%. So we go look at 4%. Oh, 0.1. For some the 2.5% should be in here. It's not. This is 0.25. 2.5% should be 10 and 11. So for the major defects, you only can have 10. You can have 10 major defects, and only if more than 10, you get 11, you will reject. So that one is 0.25%. So it's supposed to be 2.5 based on this setting. Okay. So major defect 2.5%. The accept level is 11. It's more than if it's 10. If more than 10, if we go to 11, you reject the whole batch. So for the minor defects, you look at the 4%. Okay, look at the 4%. So 4%, look at the row L again. Okay, so it give me 14 and 15. So it means that if you have 14 minor defects, everything is still acceptable. If more than 14, you get 15, we reject the whole batch as well. Okay, so basically, this is how we use the AQL table. So if someone they're working in a QC or QA, they might already know this. They might very familiar with these AQL tables. For someone that is not very familiar with this AQL, not very familiar with expressions, I hope these webinar sessions can help you, and you might get some knowledge about how to use the AQL table. Okay, so lastly, so here we come to the end of the half an hour webinar session. So thank you very much, everyone. So if you want to know anything about SolidWorks inspection, about our license, if you want to know you want me to show you some demo or some knowledge, you might just email me. So I will try to respond to you in between one business day. Okay. Thank you very much, and have a nice day.